of these elements, that is voltage and current relationship of that elements. In this last class we discussed about the passive and active elements and different types of the terminologies we discussed there. Now we discuss about the Kirchhoff's laws. So under this Kirchhoff's laws there are two types of laws. One is Kirchhoff's voltage law and second one is Kirchhoff's current law. So what is Kirchhoff's voltage law and Kirchhoff's current law? Kirchhoff's voltage law means the algebraic sum of the voltages is equal to 0 is nothing but the Kirchhoff's voltage law. The algebraic sum of the voltages is equal to 0 is nothing but the Kirchhoff's voltage law. Kirchhoff's current law means the algebraic sum of the currents is equal to 0, then it is called as Kirchhoff's current law. Kirchhoff's voltage law is also called as mesh analysis or loop analysis. Mesh analysis and loop analysis. Kirchhoff's current law is called as the nodal analysis. Is also called as nodal analysis. So why Kirchhoff's voltage law is called as the loop analysis means here the basic we have to find out the Kirchhoff's voltage law with respect to loop analysis. That means loop means it starts at one point and return back to the same point. That means the current which starts at one point and return back to the same point is nothing but the loop analysis. Loop. So Kirchhoff's voltage law means the algebraic sum of the current voltages is equal to 0 and it is also called as Kirchhoff's voltage law, mesh analysis and loop analysis. So generally why this Kirchhoff's laws will be used is generally we reducing the any complexity of the network we use this Kirchhoff's laws. That means whatever when you have to find out the voltage, when you have to find out the current, when you have to find out the power. So there is the different techniques must be there. First one is to for finding the equivalent resistance we find out the circuit, and for using the star delta transformation we find out this circuit, and by using the theorems we have to find out the voltage and the current in the circuit. Like that, this is the one of the law for finding the voltage and the current. That is Kirchhoff's laws. That is Kirchhoff's voltage law and Kirchhoff's current law. So Kirchhoff's voltage law means the algebraic sum of the voltages is equal to 0. Generally when you see this circuit, here the 4 voltages must be there, V1, V2, V3 and V4. 4 voltage sources must be there, and remaining R1, R2, R3, R4 and R5 are the resistance in the circuit. When you observe that, I already tell that circuit means it is a combination of the active elements and passive elements must be there. So here the active elements are voltage sources and passive elements are resistors. So whatever the voltage sources must be there, we does not change their polarity. We does not already the polarity will be there. The long line will be positive and the short will be negative. It is a battery, and the remaining whatever the passive elements is there, depending upon the direction of the current, we have to change the polarity. So in this Kirchhoff's laws means Kirchhoff's voltage law means first one I tell that the algebraic sum of the voltages is equal to 0. We already know that according to the Ohm's law, voltage is equal to current into resistance. V is equal to I into R. Voltage is equal to current into resistance. So for every sum of the voltages is equal to 0 means we have the equation whatever we have obtained is V is equal to I into R form. I into R form. Sum of the voltages is equal to 0. So here when you find out this, for finding the voltages or current, first you observe that how many loops are there. Loop means whatever it starts at one point and return back to the same point is nothing but the loop. So when you observe this, how many network, how many circuit is that? There is only simple one circuit must be there. If I add another circuit here, then there is the 2 circuits must be there. Then there is the 2 loops must be there. But here there is only one loop must be there. So first we observe the loop. Loop means, so how many loop means I mentioned that there is only one loop. I get the current will be I. I put the current will be I, and I start the direction like this. So depend first when you observe the loop, then you put the direction of the current I like this. Suppose that is our chance. I will be put the direction of the current in the opposite direction also, but the answer will be in the negative part. So I put the direction like this. So first, how many loops are there? Second thing, assume the polarities. Assume the polarities. So the polarities does not change the sources because it is a battery. Already there is a positive and negative signs must be there. There is no need to change the polarities. Only we assume the polarities in the passive elements. That is the resistance part. So when you observe here, the how you assume the polarities means entering of the current is put will be positive sign, leaving of the current will be put it as negative. Entering will be positive and leaving of the current put it as negative sign. So here there is a battery must be there. So I am starting the current here. It will goes like this. Entering to the resistor will be positive, leaving will be negative. Like that, entering will be positive, leaving will be negative. There is no need to change the polarities of the sources. It will be positive on the negative side, but resistor entering will be plus, leaving will be minus. Plus, minus. And here also it will be plus and minus. There is a small change here, minus to plus is there. No, it will be plus and minus. If suppose the direction will be like this, opposite, then whatever the minus signs will be there, that will be plus, and the remaining plus signs will be minus. Depending upon the direction, the entering will be put it as positive and the leaving will be put it as negative. So first we have to assume the loop, and then we have to assume the polarities. And the third thing what we done is write down the equation. How do you write down the equation? So when you write down the equation, the algebraic sum of the voltages is equal to 0. So when sum of the voltages is equal to 0 means, so how you write down the equation means, if suppose there is the, if here there V1 voltage source is there. So I telling the sum of the voltages is 0. Already there is the voltage is there. So simply you put as V1. So how you assign the sign means, here minus to plus, minus to plus, that is the rise of potential. Negative to positive, minus to plus, there is the rise of potential. So put it as positive sign. Put it as positive sign. So plus V1, plus V1. Next you go here, plus to minus. So it will be drop of potential, plus to minus, minus of. What is the current flowing in this resistor? I. And what is the resistance value? R1. According to Ohm's law, V is equal to I into R1. So I into R1. I into R1 is nothing but the voltage. The algebraic sum of the voltages is equal to 0. So I into R1 is nothing but the voltage. So plus to minus, minus I into R1. Next comes to here, plus to minus, minus I into R2. Next here, plus to minus, minus V2. Simply because it is a voltage. And here, plus to minus, minus I into R3. Next come here, plus to minus, minus I into R4. Next come here, minus to plus, minus to plus. So it will be the rise of potentials and it will be plus V3. Next come here. Here I tell that this is positive, this is negative. Plus to minus. Suppose this is plus to minus, minus I into R5. Suppose it is minus to plus is then plus into I into R5. But depend upon the direction, the sign will be this is plus and this is minus. So when we observe that rise of potential will be positive side, drop of potential will be negative side. So it is observed that rise of potential, plus to minus, drop of potential. So it is minus. Minus to plus, rise of potentials, put it as plus sign. So the algebraic sum of the voltages is equal to 0 is nothing but the Kirchhoff's voltage law. So how you find out the what is the steps to find out this Kirchhoff's voltage law means? So first, how many sources must be there, how many resistance must be there. So then first thing we observe that how many loops are there. So there is the one circuit will be there, or there is another loop must be there, but in this figure there is only one loop must be there. Then assign the polarities. How you assign the polarities? When the depend upon the direction of the current, direction of the loop, put it as positive sign. Entering will be positive, leaving will be negative. Like that we assume the signs. And the third thing, whatever you have to write down the equations. That is KVL equation. So how you write down the KVL equation? The algebraic sum of the voltages is equal to 0. So when there is the voltage source, we no need to write down into the form of the Ohm's law, I into R1. Only the voltage will be voltage, that is V1. So but how you write the equation means when there is the rise of potential, put it as positive sign. So when there is minus to plus, put it as positive sign. When there is plus to minus, put it as negative sign. Simply with that. So when there is the voltage source minus to plus, plus V1, plus to minus drop, that is minus. What is the current flowing? I into R1. If suppose, and what is the current flowing here? I into R2. Plus to minus minus. Plus to minus minus V2. Plus to minus minus I into R3. Next, plus to minus minus I into R4. Next, minus to plus plus V3. Next, plus to minus minus I into R5. Minus to plus plus V2 is equal to 0. That means the algebraic sum of the voltages is equal to 0. Is nothing but the Kirchhoff's voltage law. It is very important. First, you have to assume that how many loops are there. And second thing, we have to assume that assume the polarities depends upon the direction of the loop. And third thing, we have to mention that if will be the rise of potential, put it as positive sign. If will be the drop of potential, put it as negative sign. This is about the Kirchhoff's voltage law. So suppose here there is the another circuit must be there. So I am telling that it is plus to minus, another loop must be there. So there is the two currents must be here. This is, then we take this is I1 and this is I2. Under that equation, R4 will be depend upon both I1 and I2. So depend upon the directions of the I1 and I2, we have to write down the equation. We have to assume that polarity is the direction of the current, and then you have to assume that rise of potential will be positive sign and drop of potential will be negative sign. The total equation will become that the algebraic sum of the voltages is equal to 0. This is about the Kirchhoff's voltage law. Next thing, there is the Kirchhoff's current law. So what is Kirchhoff's current law? The algebraic sum of the currents is equal to 0. Algebraic sum of the currents is equal to 0. So this is called Kirchhoff's current law. When you observe the Kirchhoff's current law it is also called as nodal analysis. Kirchhoff's voltage law is called as mesh analysis or loop analysis, but Kirchhoff's current law is called as a nodal analysis. So nodal analysis means, what is the node means? Two or more points, two or more elements, two or more branches meet at one point is nothing but the node. Two or more elements meet at one point is nothing but the node. Two or more elements meet at one point is nothing but the node. So here we got this is the nodal analysis, but this is called as loop analysis. Why you got tell this loop means starts at one point and return back to the same point. It's nothing but the loop. In this node means two or more elements, two or more branches meet at one point is nothing but node. Branch means a line segment joined between the two nodes is nothing but the branch. So when you observe here, there is the 4 currents must be there. One is I1, another is I2, and I3 and I4. 4 currents must be there. So when you observe this, I1 current is entering to the node. I2 current is entering to the node. But I3 and I4 are the leaving to the node. I3 and I4 are the leaving of the node. I1 is entering node, I2 is entering node, I3 and I4 is the leaving of the node. So when it will be the leaving of the node, I3 and I4 is the leaving of the node. So I1, I am telling that the algebraic sum of the currents is equal to 0. So for our current entering is equal to the current leaving. Current entering is equal to the current leaving. When you observe that I1 is the entering to the node, I2 is the entering to the node. So I1 plus I2. And I3 and I4 are the leaving to the nodes. That is I3 plus I4. Sum of the currents entering to the nodes is equal to the sum of the currents leaving to the node, or the algebraic sum of the currents is equal to 0. That means I1 plus I2 minus I3 minus I4 is equal to 0. Sum of the currents entering to the node is equal to sum of the currents leaving to the node, or the algebraic sum of the currents is equal to 0. So here I1 plus I2 is the entering current, that is equal to the I3 plus I4, or I1 plus I2 minus I3 minus I4 is nothing but the is equal to 0 is nothing but the Kirchhoff's current law. So it is very important. Kirchhoff's voltage law means the algebraic sum of the voltages is equal to 0, and the Kirchhoff's current law means the algebraic sum of the currents is equal to 0. This is about the Kirchhoff's laws. So I am telling that this is called as the mesh analysis or loop analysis. Mesh analysis or loop analysis. So when you observe this, I am telling that in the last I see that only one circuit will be there. So when you observe here, there is a 2 loops must be there. There is only in the last there is the only one loop must be there. When you observe here, there is the 2 loops must be there. One is I1 and the second one is I2. So I taken the directions like this, I1 and I2. So first I am telling how many circuits must be there, how many loops are there, you observe that. So that means the sum of the whatever the current will be starts, the current will be returned back to the same point, that will be loop. So suppose I will start here I1 current, it does not go to the second because there is the one another resistance will be short here. So there is only one loop must be there, here one loop and this is one loop. So how first we observe that how many loops are there. Next we observe that how many, that is here polarity. So when we assume the polarity, so how many sources are there? There is a V1 source and V2 source. There is no change of the polarity. There is minus to plus and minus to plus is there. Next, we assume the polarities of resistances. How we assume the polarities of the resistance? First, whatever the direction of the current will be there. So, depend upon the direction of the current, then only we assume the polarities. So, when you see here the resistor R1, this resistor R1 is depend upon only I1 current. It belongs to I1 current only. So, when I am going to like this current, it's the entering will be put as plus, leaving will be minus. And coming to this R3 resistor, when the I1 is current will be entering here, put will be plus, leaving will be minus. But when you observe that this R3 current will be depend upon both I1 and I2 currents. So when you assume the polarity of the I3, so whenever the KVL is coming here, that means the current will be coming here due to the I1 current, entering will be put it as plus, leaving will be put it as minus, and comes to like return to path. When you observe this I2 loop, already there is voltage source must be there, plus to minus. So Next it comes to the R3, but the entering is the down part. So this will be plus and this will be minus. Upwards will be minus, downwards will be plus. Why? Because I1 is R2 will be belongs to, that means R3 belongs to I1 current and I2 current. R3 belongs to I1 current and I2 current. Depend upon the direction of the I1. If suppose I1 direction will be upwards, then you have to upward will be plus, downward will be minus. But I2 direction will be comes to the downwards to upwards. So downward direction is plus and upward direction is put it as minus. And then R2. So R2 will be belongs to I2 current. Then it comes to the this entering will be plus, leaving will be minus. So when you observe that I1 direction is like this, I2 direction like this, but I3 direction, I1 will be in the one side direction, I2 will be in the opposite direction. I2 will be in the opposite direction. When you observe this I2 will be reverse direction. When I2 will be reverse, then you observe that I1 and I2 will becomes to the same direction. So here it is 2 plus 2 minus, and here also it is positive to negative. So but when you observe here, I am taking this in the some opposite direction. For that point of view, you observe that this is belongs to the I1, it is positive to negative, belongs to I2, downward will be positive, upward will be negative, upward will be negative. So depending, first we observe that how many loops are there, we observe that we assign the polarities. How you assign the polarities depends upon the direction of the current. We have assigned the polarities. In the third thing, what we done, we have to write the equations. So assign mesh currents I1, I2. How many? Suppose here there is the 2 loops must be there. So we will assign I1, I2. If suppose there is 3, 4 up to n, we have to assign I3, I4. Up to n we have to assign. Next, apply KVL to each meshes using Ohm's law to expression voltage in terms of the current. According to the Kirchhoff's voltage law, the algebraic sum of the voltages is equal to 0, that is V equal to IR. Next, solve the resultant simultaneous equation to get the mesh. Next, so they have taken as equation. Generally, as per your last, I am telling that first minus 2. Generally, you take one paper and write down this equation. Minus 2 plus V1. When it will be the rise of potential, put it as positive. Next, plus 2 minus of I1 into R1. I1 into R1. Next, come to here. Here I observe that here this is plus 2 minus and minus 2 plus. But when you write down the equation for the first loop, you have take the preference for the first loop preference. So first you take the preference for the first loop current. We take preference of the first loop current. So first plus 2 minus I1 into R3. Similarly, minus 2 plus I2 into R3, because that is I1 and I2 directions will be opposite. For that you have taken as simply when you write down the first loop equation, then first current preference will be we have taken the preference of first current. When you write down the second loop equation, you take the preference of the second current. So simply you have to take plus 2 minus R3 into I1 minus I2. Plus 2 minus R3 into I1 minus I2 is equal to 0. So then now you observe that R1 plus R2 into I1 minus R3 I2 is equal to V1. Or the sum of the algebraic sum of the voltages is equal to 0. So when you take the second equation like that, similarly minus 2 plus V2. Next, plus 2 minus because I am writing this equation, but the loop will be like that. So we have to start here. Plus 2 minus I2 R2, plus 2 minus V2, and come to here plus 2 minus R3 into I2 minus I1. I2 minus I1 is equal to 0. So when you observe this circuit, you observe carefully. When R1 and R2, it will be belongs to I1, R1 belongs to I1, R2 belongs to I2. There is no problem to writing that equations. So when you observe the R3 equations, when you observe the loops there, one loop will be entering, I1 will be entering to the R3 resistance, but I2 will be the leaving to the R3 resistance. That means the two directions will be opposite. One is like this, one is forwarding direction, one is reversing direction. So for that you have to write down, when that means this R3 will becomes to first loop and second loop. When you have to write the R3 equation in terms of the first loop, then you have to observe that the first, we have to give the priority for the first loop current. That means plus to minus R3 into I1 minus I2. Why? Because I1 minus I2, because the direction will be opposite. When suppose the direction will be same direction, then you simply take that I1 plus I2. So like that, when you write down the equation depending upon the second loop, the second loop will be taken as a first priority. So for that you have to write down minus 2. Already the loop will be minus 2 plus into R3 into I2 minus I1. So here when you write down the equation for first loop, we have to put I1 minus I2. When you have to write down the equation for the second loop, we put I2 minus I1. So carefully observe that R3, when you have to write down the R3 equation, first you observe if the direction will be same on the both direction, then simply you put I1 plus I2 current. If will be opposite, put it as I1 minus I2 current. And one thing you have observed that when you write down the equation for the first loop, you have to take the preference of the first current. When you write the equation of the second loop, you take the preference of the second current first. Like that, you have to write down the equations of the mesh analysis. This is about that means the algebraic sum of the voltages is equal to 0. So this is one of the example of the mesh analysis. Simply, how many loops are there? 2 loops must be there. So I have to assume like this equation and like this I1 and I2. So already it is minus 2 plus, and you put here is plus 2 minus, and here it will be plus 2 minus. You don't change the battery size, and it will be like this. So for entering will be plus, leaving will be minus. Entering will be plus, leaving will be minus. Entering will be plus, leaving will be minus. Like that, you have to assume the size, and then you have to first you have to observe how many loops are there. Second, you assume the polarities. How you assume the polarities? For entering will be positive, leaving will be negative. And the third thing, you have to write down the equations. For writing the equations, we observe that when there is the individual resistance, for if here 5 belongs to I1 only, 6 and 4 belongs to I2 only, but 10 belongs to I1 and I2. So 10 belongs to I1 and I2. So we are writing the equation of the 10. When we have to write the equation for the first loop current will be taken as the first preference, and the direction, that is I1 and I2, they are taken as the opposite direction. Then you put I1 minus I2. If suppose when there is the same direction will be there, we put as I1 plus I2. When will be the opposite direction will be there, we put it as I1 minus I2. So we take this circuit, and simply you have to do the problem, and then after writing the two equations, the algebraic sum of the voltages, then according to the, when you have taken the Cramer's method or you take the direct equations method, you have to solve the total currents flowing in the circuit. So like that you have to, so in this simply you have to observe that how many loops are there. Second thing, Entering the how current will be plus, leaving current will be minus. And third thing, when you observe, to write the KVL equation, the algebraic sum of the voltages is equal to 0. But while you observing that, if any resistor will be belongs to two currents, any resistor belongs to two currents, then you say that any current, any resistor belongs to two current, if the both are in the same direction, put it as I1 plus I2. When the both directions will be opposite, then put it as I1 minus I2. So when you take the equation, when you write down the equation for the loop 1, I1 current is first preference, that is I1 minus I2. When you write the equation for the second loop current, I2 will be taken as the first preference, I2 minus I1. Like that you have to write down the equations. And next one is nodal analysis. Nodal analysis means, already I am telling that is the KCL. KCL means the algebraic sum of the currents is equal to 0. The algebraic sum of the currents is equal to 0, or sum of the currents entering is equal to the sum of the currents leaving. And it is called as nodal analysis. Why it is called as nodal analysis means, it will be belongs to the node. That means two or more points meet at one point. When it will be the loop analysis must be there, it starts at one point and return back to the same point. Is nothing but the loop analysis. This is called the nodal analysis. And the nodal analysis, generally we see that in the loop analysis, generally we take the circuit will be simply, that is I1 current and I2 current. But here we take in the form of the node. So in this KVL, we observe that the total equation will be formed in the V is equal to IR, I into R, I into R. But when you take the nodal analysis, it is equal to I is equal to V by R, I is equal to V by R, I is equal to V by R. So here first we observe that how many nodes are there. So this is one node. This is not a node because the two or more elements meet at one point is nothing but the node. So when you take this is as the node, there is no meeting of the another resistor must be there. So it does not a node. So node means two or more elements meet at one point is nothing but the node. So here the V1 will be there. So this V1 will be belongs to R1 resistor, R2 resistor and R3 resistor. How you write down the equations? Generally write down the equations according to the Ohm's law. I is equal to V by R. I is equal to V by R. So under this I is equal to V by R. I is equal to V by R. We observe that here V1, R1, R2, R3, E1, E2 and E3 must be there. So here first you have to write down the first equation, the algebraic sum of the currents is equal to 0. So we observe that V1 minus E1 by R1. So generally we tell that V1 by R1, V1 by R2, V1 by R3. But why you take this E1, why you take this E2 and why you take this E3 means, this in the resistance is in series with this voltage. So whenever any resistor, any voltage is series with this resistor, you write down that equations. But depending upon the polarities, when it will be the plus to minus, so there is the minus even. So suppose it will be the opposite sign, you have taken plus, but simply you have taken as V1 minus, but this is also voltage. But this is also voltage. So voltage will be upward and resistance value will be downward. So V1 minus E1 by R1 plus V1 for this resistor, R2 resistor, there is again one voltage source must be there. So V1 minus E2 by R2. Next again this voltage, again E3 will be series with the R3 resistance. So put is V1 minus E3 by R3 is equal to 0. Sum of the currents is equal to 0. V1 minus E1 by R1 plus V1 minus E2 by R2 plus V1 minus E3 by R2. If suppose this voltage source is not there, simply there is resistance are there. Simply you have to write V1 by R1 plus V1 by R2 plus V1 by R3 is equal to 0. If suppose for R2 there is no E2 is there, then we have to tell V1 minus E1 by R1 plus V1 by R2, because there is no, suppose we assume that there is E2 is not there, then you have to put V1 by R2 plus V1 minus E3 by R3 is equal to 0. So the algebraic sum of the currents is equal to 0. This is about the nodal analysis. So we tell that there is the Kirchhoff's current law and the Kirchhoff's voltage law must be there. Kirchhoff's voltage law means the algebraic sum of the voltages is equal to 0, and Kirchhoff's current law means the algebraic sum of the currents is equal to 0. But this voltage law belongs to the loop analysis. This current law belongs to the nodal analysis. Voltage law, in this voltage law, we have to take the preferences of the loops. In this current law, we take the preference of the node. So when you have to write down the equation for the KVL, the algebraic sum of the voltages is equal to 0. For that, V is equal to I into R. We write the equation for the KCL. The algebraic sum of the currents is equal to 0. So I is equal to V by R. This is the today class session.